Hello everyone. In previous video I have taught you how to create a singular circular linked list. Now I am going to teach you how to create and display double circular linked list. See. Now this is the double circular linked list. If you see in say singular circular linked list, in each node it has only two parts. The structure will have only two parts. One is data part and other will be the pointer part. The data will store the data value and pointer will store the address of next node. But in this double circular linked list, if you see, each node contains three parts. See, first part is previous pointer, which stores the address of previous node. See, 100 is the address of previous node, so 100 gets stored over here. And this is middle part is called data part. In this part, you can store the data value. I am storing 8. Now in this third part is called next pointer. In this pointer, you are storing the address of next node. Address of next node is 300. So 300 I am storing here. So there will be two links. One is in backward direction and one will be in the forward direction. This is double linked list. Now it's not just a double linked list. It's a circular linked list. That means it. See, in normal linked list, if you see there is no node after last node. This is the last node, means here in this pointer there will be 0 because no node is present after that. But here it will point towards the first node. The next node after this last node is the first node. So I have created a forward link, and same as that, the previous node of first node is, see, this is the first node. Now the previous node of this first node is last node. So I am storing the address of last node, that is 300, in the previous pointer of first node. So this is called, and there is two pointers called head and tail. Head is used to point towards the first pointer and tail is used to point towards the last node. So that's the concept of double circular linked list. Now see, now what is the structure of each node? It contains three part, data and two pointer part, previous and next pointer. So I am writing that in code. So I am defining that structure in the code. See here, struct node, then int data, the data value which we store, and that data value is an integer type. So I am writing int. Then this is previous pointer. So I am writing previous pointer. Now this previous pointer is pointing to another node which is having same structure as this node. So I have wrote struct node. Now this structure is struct node. This node, this pointer is pointing to this node. This node also have same structure as this. So I have written same struct node. Then see, this is next pointer which is pointing to next node. So I have written pointer next, which is pointing to another node having same structure. So I have written struct node. Now see. Now let's see how to create a circular double circular linked list when it is empty. See. Now let's think this is empty. No nodes are present in the double circular linked list. Let's see. So when you can say this linked list is empty? When head value will be 0, because head is a pointer which is used to point towards first node. If no node is there, means head will be 0. It does not point to any node. So this is the starting condition. Now you want to create a new node. How you can create? You want to create a new node in double circular linked list. How to create? See, first step is you are creating a new node of 3 parts. I have created new node of 3 parts. Now I want to access this node. How I can access? I should need a pointer for that. So I am creating a pointer called new node. This is the pointer new node which points towards this node. Now let's say the address of this node is 100. So I am storing in the pointer this 100. So this pointer points towards this node. Now see, now I have created a new node. Now one more pointer I will create, that is called tail, which stores the address of last node, which points towards last node. So see here, now I am taking another pointer tail, which will point towards the last node. Now see, now I have 3 pointers. One is head pointer, new node pointer, tail pointer. So I'll write that in code. See here, struct node. Now first pointer is head. Head is pointing to a node. So I'm writing head. Head is pointing to a node which have a structure. So I have written. Next node is new node, which is pointing towards this node. So I'm writing pointer new node. Now other pointer is tail, which points towards the last node. So I am writing pointer tail. I have created with 3 pointers. Now see, now at starting no nodes are present in the linked list. Linked list is empty. So at head value will be 0. So I am defining that head value is 0. I am putting head value is 0. Head is 0 I have put. Now see, now I am taking another variable called choice, int choice. This choice is used for asking the user whether he want to create a node or not. If the two options are yes or no, if the user says yes means it creates a node. If he says no means it does not create a node. So that yes or no is a choice. That's why I am creating this variable. Now see. Now while choice. This I will explain you later why I have written this while condition. See. Now I have written while choice. Now at starting see. Now the linked list is empty. When you can say the linked list is empty? When head value is 0. So I am writing that condition. See, now you have created the head value is 0, so linked list is empty. Now what you did first? Now you created a new node. How you can create it? By dynamically by using malloc function. So I'll create it. See here. New node equals to struct node star malloc size of node. Now see, now I have created this new node by malloc function, and the size of node is structure of size of this node. 3 parts are there, 4 byte, 4 byte, 4 byte. So that will be the size of node. Now see, now you should ask the user what data he wants to store. So I am writing that statement, enter data. So see, printf %d, no, printf enter data. Now the computer asks the user to enter the data. Now suppose the user says 7. Then I want to insert 7 into this. How I can insert? The computer should read that 7 as data part of the new node. So I am writing that. How to read means by using scanf function. So I am writing the code. See here. Scanf %d, comma, and new node data. Now see, now the 7 which user enters is considered as new node data. What is new node address? 100. 100 data is this middle part. So you can store 7 over here. Now I have created a node which is having data value. Now see, now the linked list is empty at starting. So head value is 0. See, I am writing the code. If head equals to 0. Now linked list is empty. Then I have created a node. Now I should fix this node as first node and last node, because when the linked list is empty, you are inserting a new node means that node is the first node as well as last node. Now see, now I should fix this node as first node. How I can fix? So you should fix means the head pointer should point towards the first node. How I can point? So I should store the address of this node in the head pointer. Then I create a link like this. So I am writing the code. See here. Head equals to tail equals to new node. I am also pointing this tail to this new node because tail is a pointer which is pointing towards the last node. Now this is the first node as well as last node. Now see. Now head equals to tail equals to new node. Now what is the address given in new node? 100. So I am writing in head 100. So this pointer points towards this node. And this tail pointer also new node 100. So this pointer also points towards this node. Now see. Now you have created a, now I'll write this tail in upside. See. Tail is 100. Now see, you have now this is, you have created a linked list having head pointer and tail pointer. But this is not just a linked list. This is a circular linked list. How you can create a circular? See here. This is in this previous pointer. You should store the address of previous node. So this is a circular linked list. So only one node is there. So previous node of this node is the same node. So you should store the address of this node into this previous node. So previous pointer. So see here. I should store 100 over here. So I'm writing, see here, how I can access this pointer part, new node previous. So I'm writing here, see, new node previous equals to head. See, now what is new node previous? New node is 100. 100 previous is this pointer. In this pointer I am storing head value. Head address is 100. So I am storing 100. Now it creates a backward link like this. So it creates a one circular link. Now this link is not enough. One more link is needed because this is a double circular link. So now this pointer, this is next pointer. This should store the address of next node. Now this is circular link. So next node of this is first node. Now only one node is present. So this is the first node. So I should store the address of this node into this pointer. So I am writing the code. See here. New node next equals to head. Now see, what is new node address? 100. 100 next is this pointer. In this pointer I should store head address. Head is 100. So I am storing 100. Now so I can create a forward link. I have created a forward and backward link. See, this is how you should now this is how you should create a node when the linked list is empty. First node you are creating when the linked list is empty. Now see, now next condition is else. That is when, see, suppose in this case already one node is present. Now you want to insert one more node, second node. How to insert? See here, it goes back and it creates a new node by malloc function. So see here, now I have created a new node. For this accessing this node I need a pointer called new node. So I created a pointer and this pointer should point towards this node. So let's say the address of this node is 200. So this pointer stores address 200 and this pointer points towards this node. Now let this program asks the user to enter data. Let's say suppose 8. Then 8 is entered into this node. Then see, now what to do? Now I should create a forward link. That means this previous node, now I should consider this as second node. I should fix this as second node. How I can fix? First step is you should create a forward link here. That means the next pointer of this node should contain the address of this node. So how to make? See here, I am writing the code. Tail next equals to new node. So see here, what is tail next? Tail is pointing at address 100, node 100. So 100's next is what? 100. In this pointer I am changing the value to new node. New node is what? 200. So I wrote here 200. So this link is cancelled and it creates a forward link. Now this pointer is pointing towards this node. Now see, next step is you should create a backward link. That means the previous pointer of this node should contain that is this pointer, should contain the address of previous node. So what is the address of previous node? 100. So I should store 100 here. How I can do? So I am writing the code here. See, new node previous equals to tail. Now see, now what is new node previous? New node is pointing at 200. 200 previous is this pointer. In this pointer I will store the address of tail. Tail is 100. So I am storing here 100. So now what it happens? It creates a backward link like this. I have created two links in forward and backward direction. Now see, the next step is what to do. Now this node should contain this the next pointer of this node, that is this pointer, should contain the address of the next node. Now this is the circular linked list. So this is the last node. Now next node of this is first node. So you should have the address of first node into this. So what is the first node? 100. So you should store 100 over here. How you can store? See here, I am writing the condition code. New node next equals to head. Now see, what is new node next? New node is 200. 200 next is this pointer. In this pointer, I'll store the address of head because head is the pointer which stores the address of first node. Now 100 is head is 100. So I'm storing here 100. Now see, now it creates a forward link. Like this, it created a forward link. Now next step is what? Say it's not finished. This is, you have created only single circular link. This is double circular link. So one more link you should create, that is backward direction. That is means what? This node, this is the first node. So previous pointer of first node should contain the address of last node. So what is the previous pointer? This pointer. It should contain the address of last node. Address is 200. So I should store 200 over here. So how to access? I'll write the code. See here. Tail. No, sorry. Head previous. Head previous equals to new node. Now see, what is head previous? Head is 100. 100 previous is this pointer. In this pointer, I'll store the address of new node. New node address is 200. So I'm storing here 200. So what it comes? It cancels this link. It removes this link. Now see, this will point to the node which is having address 200. So this node. So I'm creating a backward link. So I have created a, this is how I create. Now see, I have created a circular link. Now one more step is remaining, that is tail pointer should point towards the last node, but it's pointing here towards first node, right? That is 100. So I should move this tail pointer to this node. How to move? That I am writing here. See, tail equals to new node. Now what is new node address? New node is 200. That 200 I should store it in tail. So tail is 200 now. So this pointer will get cancelled and this tail will point towards the node which is having address 200. Now see, now head is pointing at first node, tail is pointing at last node, and all the nodes is containing two links, that is forward link and backward link. So you have created a double circular linked list. So this is how you should create a double circular linked list. And then next step is remaining, that is see. Now you want to ask the user whether he want to create a node or not. So I am writing that, see here. Printf, do you want to continue? That is 0 or 1. Now see, now you are asking the user whether he wants to create a node or not. You are asking him to enter 0 or 1. If he enters 0 means he does not want to create. If he enters 1 means he wants to create. So that 0 or 1 is a choice. I should set that value as choice. So I am writing here, see, scanf %d comma and choice. Now see, now if the user enters 0 means choice is 0, so he does not want to create, so it comes into this thing, choice is 0, so it does not enter into this code, it does not create new node. So that's why I'm writing while choice. Now if he enters 1 means the choice is 1, so it enters into this code, it creates a new node, it prints the data in it, and previous pointer, next pointer it will store. So this is how you should create a circular linked list, double circular linked list. See, now I'll teach you how to display all the elements present in the circular linked list, double circular linked list. See, first step is you should create a pointer called temp. Now see, now the data present here are 8, 11, 9. It should display 8, 11, 9. How to display it? Let's see. See, first step is you should create a pointer called temp. See, this is the pointer temp, and this pointer should point towards the first node. So I should store the address of head. Head is 100. So I should store 100 here. Then this pointer points towards first node. This is the first step. So I am writing the code here. See here. Here pointer temp. Pointer temp, and that pointer is pointing to a node having this structure. So I'm writing struct node. Now I have created a pointer temp pointing toward a node which is having some structure. Now this pointer is pointing to which node? That is first node. So I should store the address of head value. So I'm writing equals to head. Now see, now I have created a pointer temp and pointing to first node. Now next step is what? You should print the data. Now first step is you should check whether the linked list is empty or not, because if the linked list is empty you can't print any elements, you can't display. So how to check whether it's empty? If head value is 0 then it is empty, because head is a pointer which points to first node. If no node is present means head will be 0. So I'm writing that condition. See here, if head equals to 0 then print empty, printf empty. Now see, now next step is this temp pointer is pointing to first node. Now you should print, now it checks whether head is 0 or not. No, head is 100, so some node is present. So now temp is pointing at first node. Now you should print the data present in this temp address. So what is the temp address? 100. 100's data is 8. So 8 should be printed. That is the first step. So I am writing the code. See here. First step is print the data present. So printf %d comma and temp data. Now see. Now what is temp data? Temp is 100. 100 data is 8. 8 is printed. Now next step is you should move the temp pointer to next node. How you can move? So I am writing the code. See here. Temp equals to temp next. Now see, you should update the temp pointer to temp next. What is temp? Temp is 100. 100's next is 200. For moving this to next node, you should have this temp pointer should point to address 200. So you should have the address of 200 into this. Where you can get address 200? By using the next pointer of this node. So I am writing temp next. 100's next is 200. That 200 I am putting here. So now this pointer is getting cancelled and it moves to here. Now the same step is done. See, this is the 2 step. Now you should go to again back step, that is print. So it prints the data present, that is temp data. Temp is 200, 200 data is 11. So 11 gets printed. Now temp equals to temp next. So temp is 200, 200 next is 300. So I am updating this temp pointer as 300. So this pointer points towards the third node. Now see, now again go back and do the same step. Print the temp data. Temp is 300. 300 data is 9. So 9 gets printed. Now temp is updated to temp next. So temp is 300. 300 next is 100. So this is written 100. Now see, now you should move back to same thing. Now see, now you should not print the 8 again, because this is a circular linked list. So you should not print 8 again. So you should stop here. So for that I am writing the condition. See here. While temp not equals to tail. See, this is the condition. That means when temp is pointing here, see, suppose at this 200. Let's say temp is pointing at 200. Now see, temp is 200, so it's not equals to tail. Tail is 300. So it prints the data. It enters into this condition and prints 11 here. Then it moves to next pointer. The pointer moves to next node. So it becomes 300 here. Now this pointer is pointing to third node. Now see, now again it checks back whether temp is not equals to tail. Temp is 300. Tail is 300. So 300 is equals to 300. So it does not enter here. It does not print the data 9 over here. So, but you need 9 to be printed. How you can print? So I am writing the next step. See, I am writing this print statement outside of this bracket. Printf %d comma and temp data. Now see, now temp is 300. 300 data is 9. 9 gets printed. Then this will not be moved. The temp pointer will not move to the first node. It gets stopped. This is how you should display all the elements present in double circular linked list and create the nodes in double circular linked list. That's all for today, and thank you. If you feel my teaching is good, then like my video, and if you have any doubts or if you want to give any suggestion, then comment on my video and share my video, and don't forget to subscribe my video. Thank you.